Hello. Alright, so this is going to be the last video for the 300 series and the most important one. If you want to expand your knowledge and know, and basically if you know how to use Matlab, this is going to be very, very helpful for you. So in this video, we'll talk about how you can export your data from Visual 3D to Matlab, complete any biomechanical analysis you want, or like any statistical analysis, any filter, anything that you don't have access to on Visual 3D, and then import those data back in Matlab to continue doing your biomechanical analysis. So this is very helpful if you want to keep visualizing your data and run more specific biomechanical models or specific analyses in Visual 3D. So if you go to the Matlab link in CMotion wiki, you'll find all of these helpful tools. So this is a helpful diagram to show you what the process looks like. So basically, we start from Visual 3D, unprocessed signals, you export that in mat file, and then load it in Matlab. And then, so we're not gonna specifically use this method, we're just gonna use a similar method, but not this way. So they use the .exe way to load into MATLAB, but we'll use the .mat method to do that. So then we process our data in MATLAB, then we'll load it in to Visual 3D back again. So what we'll use is that we'll use the pipeline command called import data from my export data to mat file, and then import data to mat file. So this is what we'll do. Again, like I told you, I'll provide all of these pipelines, but I created all of these pipelines. All right, so as always, we'll start with like by saving our files, just to make sure that in case we mess up or in case we need access to the workspace that we created before, we always have that. So I'll save our workspace, and then basically select the active files. I'm just gonna work on this specific file, but you can work on all of the files that you have in your workspace. Alright, then we'll use this export data to mat file. Basically, when you go here, when you go to the command centers and you click on MATLAB, you'll find all of these commands in here. We'll specifically use these two. So export data to MATLAB, and then export data to mat file, and then load, and then import data to mat file, just to make our life easier. But you can explore all the other methods. Alright, so when you export your data to mat file, you can either do it like the more user-friendly way, or you can do it by hard coding your this is the signals. So what you need to do is, first of all, type in the signal type. Because I'm exporting, this is going to be basically a continuation from the previous video, and what I'm gonna do here is show you the third method on how you can downsample your data outside of Visual 3D, so on Matlab, and then load it in back to Matlab. But this applies to anything else you want to do. So in this method, I'm gonna export all the force plate data, and in here, you can see that I added all the 10 force plates, and then also you have to load in like the origin, like the type, the folder. So 10 original folders, and then 10 force plates. So from FP1 all the way to FP10. In the file name, you have to specify the whole path of the folder that you want to export your data at, and then type the name of the file that you want to export, and then make sure you add .mat. So the file format that Matlab understands. It's a Matlab data dot mat. The Matlab codes is .m. Alright, so and then in here Matlab names, this is just the names that Matlab will read in, so you can just type the same names or any names you want. I typed the same names to make my life easier. Alright, so I'm gonna go ahead and execute the pipeline, because once you export your data to mat files, I basically added a pipeline breakpoint. So when we actually export the data from Visual 3D, it will stop the pipeline and then waits for us until we finish our processing, and then we will import it back to MATLAB. But just so you know, before we actually start working on MATLAB, the way to import the data is just basically the same thing as you export it, but you just give it the names. The only difference here is that, so we'll give it the signal type, so where you want to load in your modified data. So here I loaded in derived, and then the folder I just gave it a new folder name, kinetic, and then here the signal names I gave it the same force plate names, but I added like mocap hertz underscore mocap hertz to make sure that it is. And then the MATLAB names, I named them in MATLAB this, like FP1 underscore 100 frames per second, but you can name it anything you want, but make sure you type the same names that you have written in MATLAB. Alright, so when you execute the pipeline here, will ask me to save it. I'm just gonna go and save this in here. Alright, so now it stopped the pipeline. I'm just gonna keep it like this, and we'll switch to MATLAB. Alright, so this is a script that I've written here. So let me just clear the whole space. So we start from the beginning. So we are in the same folder that we exported the data at. So I exported it in this V3D tutorials 300 series and named it force plates data.mat. So we're gonna load that mat, like the data files to like MATLAB, and I will give you this script as well. So I'm just gonna run this, and then we'll have this is what it will look like when you load it into MATLAB. Because we loaded in the force plate, alright, so because we loaded in all the force plates, you only see the force plates. For example, let's go into force plate number 5. This is what it looks like. We'll basically export it as struct arrays. Within each of those areas, because we only exported one file, we will only see one here. But if you have, like, let's say 10 files or 3 files, you will have, each file will have its own struct area in here. And then when you go inside, you'll find these columns and rows. Again, if you remember from the previous video, I did mention to you that Visual 3D creates only one column for each axis. That's why here you see the data goes all the way down to 49,000 frames. So now we want to downsample this data. For example, if I want to plot this data, it will be like FP5, and then we want the struct array FP5 1 1, and then we want to like plot, let's say let's plot all of them. So we plot all of the rows and all of the columns. So this is what it looks like when you plot it. You see we have like 49,000 frames, and it's not downsampled, it's at 1,000 frames per second. So what we need to do is downsample them. MATLAB has a function called downsample. When we go to MathWorks and let's just type downsample Matlab, we'll basically like, not this, downsample. So downsample, what it does is that it will decreases the sample rate of x by keeping the first sample and then every nth sample after the first, which n is basically the integer. If x is a matrix, it treats it as a column in separate sequence. So downsample the sampling rate of a sequence by a factor of 3. We want to downsample it by a factor of 10. So we'll use that. So what it does basically, if you look at here, has 1, 4, 7, 10. If you downsample it by that factor, it will just skip the first 3 and then it will use the third after the first. So like it will put the first number and then it will pick the third number. But if we use 10, it will just pick the 10th number. So that's what I used here. I created the for loop of a equals 1 to 3, so we don't have to just write each line for each axis. So then each line will be written for each force plate, so FP1, FP2 all the way to FP10, and then I named it 100 frames per second because we only have one file. Again, we only use the first struct, and for the first column or first row of that struct array, and then I'm using A to replace the axes, so X, Y, Z, and then we're using all of the columns. And then we use downsample, so we're downsampling by a rate of 10. So let's run this. So once we run this, you'll see all of these new variables that were created. So for example, FP10, you will have like, the original one will have 49,000, but FP10 of 100 frames per second. Again, you have to also save it as a struct array because that's the only way that Visual 3D will understand it. So saving it as a struct array with X, Y, and Z coordinates, but now we downsampled it to the same sampling frequency as the motion capture. Alright, so once you downsample your data, you basically save it as a MAD file. So here what I did is I saved it as the same name, but I gave it an underscore out, so output, just to differentiate between both. So we're gonna go ahead and run this section, export, and now we actually exported that. So when you go back to our folder, you'll see that the new mat file has been exported right now. Alright, so now what we need to do is go back to our Visual 3D, and we can resume the pipeline. But just make sure you have the name and everything correctly. So let's resume the pipeline, and then it will give us 0 errors, so everything has been exported fine and imported fine. So when we go to the file that you chose here, so derived, kinetic, and all that. So when you go to derived and when you go to interesting, why did it not? Maybe I did halt it. Okay, probably I did not resume. So let me execute it again. And then let's resume. So now we actually resumed. I probably like halted it earlier. And then we hit OK. So now when we go to our derived, you see the kinetic folder has been created with all these downsample data. So when we open any like FP5, you'll see our data are actually downsampled to the frame rate, the motion capture frame rate. And it does say here 100 frames per second if you see it. Alright, so this is a very useful tool, like I said, to not just run this, but complete any data analysis that you want, that you can't do or complete or run in Visual 3D. Alright, well, I hope this tutorial has been very helpful for you. And again, if you need any help or have any questions, you can reach out to me by email. Thank you so much, and have a great day.